Okay, let's get started. And the first thing I want to do today is announce the Linux tutorial, which is this Friday. I mean to make that larger. This is this is a quarterly event that the Computer Science and Engineering Club puts on. And basically the intent there is to get people who are new to the labs here and to the Linux command line and the Linux systems in general, to get people familiar with the machines and how they're used in the labs. The new people coming in, the people in this course and some of the other courses. So this is well worth your time. It's 2 to 3 this Friday. I highly recommend it. Even if you want to go just for a review and maybe to meet some of the members of the Computer Science and Engineering Club and get connected with that network of people, because that can be very useful to you as you go through your studies here. It's a very practical social club or student club to be a member of. All right, so I'm going to just launch into Lab 2. Let's do Lab 2 together today and see how that runs. Are there any questions that someone wants to ask before we get started? Yeah. Turning in Lab 1? Yeah, I think, when is the deadline? Did we pass on that? Today. Yeah, so this is today, right? So you can get this done by midnight, right? How do you turn it in? Go to Blackboard. Log into Blackboard and find the course, and you'll see there's a vertical menu of choices, and pick lab assignments. When I went into the labs last week, yeah. It said, like, did you complete the lab? And that's it. You just say yes. Right. You don't have to actually turn in anything? No, not on Lab 1, okay. But for Lab 2 and afterwards you do. And I'm going to show you today how to turn in that material for Lab 2. Okay, so we'll get that established. All right, let's take a look at Lab 2. So here are the learning objectives. Learn how to use a version control system. And that's in fact how you will submit your materials. Right, your solutions to the programming problems will be submitted using a version control system, just like a professional programmer would commit, changes to a project into a central repository. That's what you're going to do. And then the grader for the course, Jaron Willis, will check out your work and apply the criteria that is described in the syllabus. Right, it has to be well written, has to run correctly. If it doesn't compile, it gets 0. So don't even bother to submit something that doesn't compile. It's not going to get any points at all. It should compile at least. And because that's not hard to do. It's not hard to get it to a point where you compile. And so on. So you can review the criteria in the syllabus, the criteria that we use to grade your submitted work. So you need to submit your work to the repository, and you also have to go into Blackboard and check off, I did it. Okay? So you don't submit anything in Blackboard other than just checking off to say that you did such and such a problem. And then what the grader is going to do is he'll review your code and apply the criteria, assign a grade in Blackboard. And then you can review his comments in Blackboard. Okay. So if he gives you a grade that's less than perfect, he will add a reason for that. So you can look at what those reasons are. All right, let's get started, and we're going to do this as if we were, say, at home. Right. So I want to review the steps that you would go through to work at home. Or on your laptop. You could be sitting in the lab and working on your laptop. You would follow the same steps that you would at home. And the first step is to, on Windows anyway, is to start this program called PuTTY, or you can have an alternative to this. It's called an SSH client, a secure shell client. That's SSH. And we'll log into this this computer here. It's called jbh3-1.cse.csusb.edu. That's called the domain name of that machine. And this is the login that you use in the labs, not the repository login that I emailed to you. First, yeah, first initial of your first name followed by 7 characters of your last name. If you're not sure about whether you can log in or not, don't test it at home. Test it here. Just go into the lab, spend 60 seconds to log into your account, and then log out, just to make sure that you know how to log into the lab machines. And then you can try it at home. Now, once you're in JBH3-1, you can see that here in the prompt. Let me increase the font size. And I'll take the colors off, and the font size will set at, I think it was 16. There we go. You can see here the prompt. Is that, you want me to make that larger? Is that okay? Maybe I'll make this one a little bit larger. In the prompt, you'll see the name of the host. Here it is, JBH3-1, and Turner, this is the username that I'm logged in under. And we need to do another hop. Now we're in sort of this gateway machine into the computer science network. Let's log into one of the machines in JB359. So we just pick a number. Pick a lucky number, 7. This is saying, well, I've never logged into this machine before, and we didn't store its public credentials, security credentials. Do you want to accept those? I'll say yes. So you only do this for once. Whoops. Okay. All right, so now we're logged in here, and let's change the directory, the current directory, to CSE201. Use the ls command, and we can see we have, we created this file, main.cpp, last time, and we ran out of time, so let's take a look. This lab 021. Let's look at that. Actually, what I'm going to do is go back to the instructions. So here we've done it. When CD by itself, by the way, I just put that there. CD by itself does what? Change directory to where? Your home folder. And that works under Windows and Mac and Linux everywhere, because we're on Linux. So that means go to your home. So I'm just doing that. I don't know where you are when you're doing these instructions. So I say CD just so that you can go back to a known place. Once you get home, then the second command is to make this directory under your home directory. In fact, let's go ahead and do all that. So CD, now I'm in the home directory. That's my home directory. That's a different path than the path to your home directory, but it's still a home directory. Let's make the directory CSE201. Now I can CD into that new directory. Whoops. As you can see, it's empty. So those are the first two commands that you can execute after logging into the machine. And then the next thing to do, and this is, I recommend that even if you have this CSE201 directory already, I would redo all these steps just the way I did it. I moved your existing directory somewhere else, call it save or old 201, whatever, and then recreate it and get it configured so that it that it becomes a working copy of the repository. So let's go ahead and copy this line right here. And what are we doing here before we do it? Check out your empty repository into this folder. So we have a repository which is empty at this location. In fact, we can get there over the web. And this is what you should do, as you're working, to verify that after you're done your work and you think you've committed your work into the repository, just use the web browser to go there and make sure that your work is actually committed. So this part of the URL needs to be personalized. So this is your Subversion username. And this is the format. So you have first name followed by last name, and the case is important. As an uppercase D, uppercase T. So everyone, I use the same kind of naming policy for everybody in the class. Once again, I'm doing this over HTTPS because we're transmitting a password. And but I'm too cheap to buy a security certificate. So we have to use what's called a self-signed security certificate. So you need to actually accept this. And I don't think security is that critical. It's not a typical application that hackers are trying to break in through. So I don't, I'm not as concerned about this security as I am to do something like to put up a public wiki and things like that. There I think a lot about security because that's a typical target. This is not a typical target. So I cache my password. Here it is. This is the name of the repository that appears here in the URL. That'll be your Subversion username. And then it gives the revision number. It's revision 0. No, there's nothing in there. And you see there's a slash. It's empty. So this is the starting point. We have an empty repository. So what we want to do is issue this subversion command, Svn. All of the command line commands that we will issue will start with Svn. That's an abbreviation for subversion. And following this is the name of the subversion client, and then we have like a subcommand. This is CO is short for checkout. We're going to check out the repository. Normally you're only going to do this once for the quarter. But you can actually, delete your work or make a copy of your work and check out the repository any number of times you want. That's okay. If you work on multiple machines like I do, you can have your copy of your repository checked out on all of those machines. That's why you can work in the lab, you can work at home, you can work on your laptop or desktop machine at a friend's house. In all of those environments, you can check out a working copy of your repository. So you can have multiple copies of your repository checked out, and you can work on that wherever you are, and then just commit your changes into the server, and wherever you sit down next, you synchronize with the repository.
It's specific to the computer that you check it out on?
The working copy is stored locally on whatever computer you're working on. It's a copy of what's in the central repository. So you check it out, You get a local, then you modify the local copy, and then you write your changes into the central store. And then you go somewhere else, then you want to get those changes from the central store. So you're like synchronizing with that central repository. All right, so I'm going to copy this whole command here. And actually, you know, what I did here was I CD'd into this CSE201, but the command should be issued after making this directory, but not changing into it. If you want to change into it, then you need to replace this. That's the target folder. Replace that with a dot. So this is the target folder. So we want to check out the repository at that URL. That's the source. This is like a copy command. Copy from the source to the destination. The source is at this URL, and the destination is here. Now, this destination makes sense because we didn't CD into CSE201. But I did already, actually. So I would want to change my destination to dot. So I would end up doing this because I'm already in CSE201. Remember, that last argument is the destination folder where you want the working copy stored into. Is that clear? Yeah, I need to change that. That's right. But I'm going to redo that. I'll use the form of the command that I show in the instructions. So I CD'd up to the working my home directory. So now I'll leave it like this. So I'm in the parent of CSE201. That's why I can use CSE201 as my target folder. Yeah, that's a required argument. So dot means current directory. Dot means current directory. And that means current directory in Windows, Macintosh, Linux, BSD, probably almost every operating system, right, you can think of. And dot dot means parent directory. So those are two special characters when you're in the file system. Dot dot means refers to your parent, and dot refers to your current directory. All right, now we need to modify the command. You have to put your Subversion username in there. There it is, Svn co check out, and this is the source, HTTPS, and so on, space, destination folder. Now, I did this already, so I cached my password already. And it didn't ask me for my password. But the first time you do this, it will ask you for your password, your Subversion password. And so type that in. And also your Subversion username. It will ask for your Subversion username and your Subversion password. You need to type those in. And then it'll ask you, do you want to save that password, username and password, so that next time you don't have to type it in again? I say yes. I cache mine. It's because you interact with the repository a lot, so it's very convenient to cache it, although it does increase some risk. Now if I do ls, well, let me cd into 201. Get rid of that mess. If I do ls, I see nothing. But there's actually something there. The Subversion control folder .svn is there. To see it, we need to tell the ls command to list all. So you used a -a flag. And you can see there, so list all. List everything in the current directory. And don't leave things out for the convenience of the user, me. Give me everything. Oh, so what is everything? Well, there's dot, I mean, that's just like the self. There's dot dot, that's the parent. And then there's dot svn. So anything that starts with a dot, anything that's named, anything that has a name, a directory or a file, if the name starts with a dot, it's considered hidden. And the file system tools that display the contents of folders will not, by default, display hidden items. You have to tell that file system tool, such as ls, to display the contents, all the contents, including the hidden elements. Now, this works on Macintosh, but that's not how Windows works. Windows has another approach to setting files as hidden. And they do have a hidden attribute. You attach it to a file. And so you can turn the viewing of hidden files on and off. So you configure that file system viewing tool called Windows Explorer. That's what it's called. It shows you the hierarchy of files in your computer. You can configure that so that you can have all hidden files and folders shown or not. By default, it's turned off. So I always turn it on because, you know, I'm a programmer. I need to see what's there. All right. So that's it. Let's go back to the instructions. And so we CD into the folder, which we did, and then we make the subfolders for the assignment. So there's two exercises in the assignment. There's problem. This is lab assignment 2. And there's problem 1 and problem 2. So we're going to put each solution, each problem that we solve, we will have a folder for that solution. I just typed it in, I just pasted it in from copying it from the web. There it is. So these are now empty. And let's go ahead and add them to the repository, to the working copy. So it's Svn Add Lab 021. And it reported something to us. It displayed this character A. That means it added something. And then it displayed the name of the thing that it added. It's a folder. It's the same thing for a file. Let's do the other one. We're going to add to Lab 022. Now, these are scheduled to be written into the central repository. They haven't actually been written into the central repository. These commands have modified that .svn folder. And it's essentially, these folders are now scheduled to be added when we issue the commit command, which is to write all of our changes into the repository, that these additions, you know, will have an effect on the central repository at that time. So if we go back to the website here and you know, we refresh this page, we won't see anything yet because nothing has been transmitted to the server. This is the command here, Svn Commit. That's when we actually transmit information to the server. This is just getting ready for the commit. We've scheduled these folders to be added during the next commit. All right, let's do this. Let's do the exercise, and then we'll go ahead and do the commit later on. Write a console program that prompts the user for their name and then displays the sentence, "Hello, user's name, nice to meet you." Okay.
Professor,
Yeah.
is there any way we could do the triangle one? Because we did this one last week.
Well, I want to do it fast, and then I'll show you. I saved it actually. Let's copy it from that old 201.
Yeah.
So the suggestion is to skip over this because we looked at this already. So, but there's people who say they want to review it. So no skipping in the back. Looks like we're going to need to review. Okay. Let's review the procedure. We create a file. Well, I'm using VI, but you know what? Even though I'm more comfortable using VI, let's use Nano because that's what you'll be using probably. And write a program that does this. Well, instead of writing the whole hello program, let's start with a hello program. It's in Lab 1. Where is that thing? Hello program. It's not in Lab 1. So all projects start with a hello program. There's the hello program. And we went over this last time. This is the include, right? IOStream is it's a library. It's part of the C++ library, standard library. And we say we want to use functions from that library. We want to use cout. That's cout down here. Cout. And we want to use this output operator. Those are all elements of this library. And we have to tell the compiler that that library we want to use. We're going to use elements from this library. So please look here to find the definitions of these identifiers. And you'll see as we go along, we'll include other libraries as well. And I think so this is called a header file, actually. Not sure it's maybe library. It's a piece of a library. It's not a complete library. It's a piece of a library. So, and then we also want to say that we're using namespace std. This cout is defined in a namespace called std, and we're just saying that everything that's in that namespace, let it become visible to us. And I'll talk a little bit more about that later. But for now, I say for this course, you don't have to think much about it. Just include that in all your programs. Oh, maybe I'll talk about it a little bit later. This is the entry point, main. So when the compiler builds the executable, it needs to know, where it needs to know where the entry point is, because it has to store that somewhere special. It has to configure the executable file in a way that lets the operating system know where the first machine instruction is to execute. So we have to have a main. There's some variation here. Maybe we don't have to return an int. Maybe we could return a void. But there has to be a main. And different compilers enforce different requirements on the structure of main. This version of main here works on all compilers. Some compilers will accept this. If you omit int and you put in a void, or if you omit the arguments, you can omit these arguments, and your compiler might take it and produce the executable. But that's compiler dependent. This is the long form of the main declaration that works everywhere. And then we have the opening brace and the closing brace here. And that cordons off a block of statements. And every statement in the block is terminated by a semicolon. So you could break this out into multiple lines like this. We could do this. That's one statement. Because all the line breaks that we put in there are essentially ignored by the compiler. That's just for human readability purposes. But you can't do that. That won't work. Because we're inside of a string a definition. And so that will break the code. All right, let's write this out. Control O, and then Control X. You'll see that we're in the wrong folder. See, inside lab 0201, there is nothing there. So I'm going to move. I made a mistake. I wanted to create that inside that folder. So let's move it there. Let's move main.cpp into lab 021. Do an ls. It's not there anymore. Let's cd into that lab, into that folder rather. And there it is. Okay, that's where we want it to be. Let's compile it. No problems. Well, no, I won't clear that. Let's run it. There it is, hello. Okay, that works. I'll use the history key. So I'm a little lazy here. And actually it would be faster if I typed it in. So we re-execute that command, nano main.cpp. Now let's, now that we have our hello program running, we got the compiler working, we've got our directory set up, let's go ahead and implement this requirement here. The console program should prompt the user for their name and then display something. Let's prompt the user for your name, for our name. Oops. Huh. I'm in. How do you copy a line? Cout. What is your name? And I'm going to put a space here because the user is going to start typing their name. I want a space after that prompt. What is your name? And notice we don't have a /n here. I'm not going to go to the next line. The user will type in their name, then we'll go to the next line. You know what? This is too slow for me to use. I'm going to have to go back to VI, and I'm going to use screen, just to speed things up. Hello, what is your name? Oh, we didn't read anything in. So we'll need to read something in. So we'll declare a variable called name, which is a string. And then we use the input operator with cin, which is the standard input stream, and we'll read into name.
How do you get it to have, like, when it says, like, hello, so-and-so, nice to meet you?
Yeah.
How do you get it to put a period after their name?
Well, you have to, you just have to print things at the right time. Well, let's see that. Let's see how to do that. Let's see how to do that. So this is hello. Let me go back to see what they have here. Hello, comma, user's name, period. Nice to meet you. So it's hello, comma. Oh, also we're going to need a new line here. Oh, no, we don't need that new line because the user's going to hit enter in the console window. So hello, comma. Then we're going to print the name. Notice I don't have quotes around the name because we're printing a variable. We're not printing a string literal. This is called a string literal. It's what it is. This is not what it is. This is what it represents. What's stored in the storage location that name refers to.
So you don't need the
Quotes?
yeah. No, the less than sign.
Oh, I'm sorry. Thank you. Thank you for correcting that. We need the less than sign. Output operator. Or what did Manuel call it? Or, the waku waku?
No, waka waka.
Waka waka. The waka waka. Okay.
Bear.
What?
Fozzie Bear.
Wazzy Bear?
Fozzie Bear from the Muppets. Waka Waka.
Oh, hey, that's my generation.
Thank you very much.
The Muppets. Yeah, I don't remember them. They still have Muppets on TV?
Yeah, Professor Murphy is the one that taught that
Oh, really?
here.
Oh.
So it seems like everybody that had Professor Murphy
Yeah.
knows the name of that.
Oh.
But everybody that didn't take him, don't know.
Oh, he's just made it up then, yeah. I think over the years he was just sort of tired of answering, oh, it's the output operator. He just made a cute name for it. So after that, we want to see, we print the period right away.
Oh, okay.
And, or nice to meet you, was it? I can't remember. Let's do it. Nice to meet you with another period. And I'll just put another new line in there. What is your name? Dave. Hello, Dave. Nice to meet you. See, I got the spacing just right, didn't I? And I want you to get the spacing right, too. There should be a space after the comma. There should be a period. There's no space after the E and the period. You know, that kind of precision is, you know, what I'm expecting you to achieve. Don't be too sloppy. Say, oh, I got the run, you know. No, I want you to clean it up, make it neat. I want your code to be neat as well when you submit your code. So there it is. All right, let's do this. Let's commit the work. So here we're going to CD to the CSE201 folder, and I recommend all commits to be done from the CSE201 folder, just to keep things simple. So I can get there by going up a level. Now I'm in that folder. But I could get there using the form that was on the web page, which is tilde CSE201. Does everyone know what the tilde means?
Your home directory.
It's your home directory. I don't think that, does that work on Windows? No, that does not work on Windows, but it works on Macintosh. For Windows, I think they use something like this. That's your home directory. Yes. All right. It works on Linux too, actually. I think it's, you can look at the value of things like this. So you do home. See that? $sign home. But on Windows, it would be home with %signs around it. No, that doesn't do anything, see? Okay. So here we are, and I'm going to exit here. We're done this. And see that a.out? We don't really need that. We could delete that because we can always regenerate it, or we can just ignore it. We don't really need the a.out into the repository. So I wrote out the commands in the lab so that you would avoid writing the a.out into the repository. Actually, last quarter we had some trouble writing the executables into the repository. And I don't know why, but I don't want them in there anyway. So I recommend not committing your executables, the a.outs or whatever you're going to call them, into the repository. They don't need to be. In general, the policies, the guideline is this. When you're working with a source code repository, it's for storing source. Anything that's derived, like an executable that's generated, you don't store it in the repository. That's the rule. Don't store derived objects in the repository. Don't store the results of your builds or your makes into the repository. All right, so we're going to use this add command here. So it's Svn Add. We used this on the two folders already. Now we're going to use it on a file. And it will be this main. So first we have, because we're in CSE201, we want to add first the folder name, and then inside the folder we do a slash. That's the path separator character, slash, and then the name of the file that we want to add. There it is, the same result. We got an A showing that's an add, and then the name of the file. Actually, the whole path name here. And now we'll commit. And look, the commit takes a this -m parameter here, and followed by a string in quotes. And this is a message or a comment. M is for message, but it's a comment. So every commit has a message or comment attached to it. If you omit this, it will launch the default text editor on your system and force you to write a comment. So it's much easier just to use this -m on the command line. In fact, I don't really care about the comment. And although it's good practice in a real project to use comments, okay, because the other developers need they need a quick way of seeing what that commit was all about. But we don't really need to see it. So you can leave it blank. So you could just have a quote, and I'll show it to you blank. So it's Svn Commit, and here's the comment, -m space quote quote. So it's two quotes. It'll take an empty string as a comment. That's acceptable. But it's forcing you to make a comment. And let's go back to, before I issue that command, let's go back to the website. There it is. That's the view of the repository. You can't see this because you don't know my password. If you go to this URL, you won't be able to look at what I'm showing you because you don't know my password. Just like that, to access the web view of your repository, you'll need your password. I'll be able to see it. The grader will be able to see it as well. But everyone else, they don't have your password, so it's private. So I'm hitting refresh on this, and you'll see there's nothing there. Let's commit. There it is. Transmitting file data, committed revision 1. Revision 1. Go back to the web. Now I hit refresh. There it is. The two folders. Here's the folder, lab 021. There's the main. There's our code. We can view it online. And here's the other folder. That's empty. That's the process. Now, it won't always go this smoothly. There's going to be mistakes, right? Sometimes the network will be down, or something got added wrong. There's been a collision. Maybe you're working on two machines and you have a conflicting commit, and the system doesn't know how to merge two files that have conflicting edits. You know, there's all kinds of potential for problems, and they're going to happen this quarter. Unless you're lucky, and then you don't have any problems. And I'm showing you the sequence of operations to guide you past all of the potential problems. So the sequence of steps that I presented in the lab, that I wrote up in this lab that I just presented to you now, I designed those after several quarters of using this in my class, so to avoid some of those problems. A lot of problems comes up when people are trying to commit their executables, the a.outs, or if you rename it, if you use -o and name it something else. Don't commit the executables. And then there's some other problems too. But if you do have trouble committing your work, then talk to me. And the lab support people are not that good with Subversion. So you can ask them for help, but if you're stuck and they can't help you, then you need to come to me. And you can always catch me in my office. Swing by my office and say, I can't commit. I'm stuck or something. And I'll just have you quickly log in. I'll look at the problem and we'll fix it together. Okay? So don't get stressed about committing things into the repository. It's not a big deal in this course. It's a little tricky and it's prone to errors, and things are going to need to get fixed. But it's not something that you have to worry about. You need to worry about coming up with algorithms and understanding the C++ language. That's the part that you need to put effort into. All right, so anything else? Yeah.
When you use the Svn Add command, that's adding whatever you just that text string, that file, and that adds it to your working copy, correct?
Exactly.
And when you commit it, you submit that back to the central location.
Exactly.
Okay. My question is, if you don't commit that work, it doesn't get added to doesn't get sent back to the main server, right?
That's right. If you don't do a commit, if you don't issue a commit, it won't get sent to the server.
But does it still exist on your local machine?
It exists on your local machine. That's right. Huh?
For how long?
Well, I mean, until your account gets wiped out. I mean, probably as long as you're a student here. Yeah. Well, unless there's a crash and your data's lost or whatever. So this is a good backup system as well. And by the way, if you're working on a problem and oh, it's time, I got to go to another class, you're in the lab, do a commit. Commit your work. Get it up there. You know, because there are sometimes problems, and maybe you were working in a lab, you want to continue work from home. Commit where you're at. It's like a backup. And the next time you sit down, you just start again. Now, if you sit down at a different machine, then you need to do an update. You need to do Svn update to synchronize with the repository. And if you're in that working mode where you're on more than one machine, like here, we're working on one machine. I mean, if you use SSH and log into JBH 3-1, you're just on one machine anyway. You're working on a lab machine. Well, one of the lab machines, but they all share the same file system. So you're essentially working on one machine in this class. If you're building stuff, you're working on Macintosh or Windows, and you're running a local compiler, and not the compiler on the lab machines, then you're working on more than one machine. So in that special case, maybe you want to talk to me, and I'll help you figure out the pattern that you're going to follow and give you the extra information you need to know to do updates and so on. Okay? How many people are building outside of the lab on their local machines? Well, that's a lot. How many people are using Visual Studio? Okay. Yeah, I mean, I'm free to answer questions. If you get stuck on something, show it to me, okay? That'll help you fix problems. But that's good to do that. I encourage that. All right. Let's do the second exercise. Triangle. So basically we want to print this. Okay, let's do that. I'm going to copy the main from what we just did. You see the command? CP copy, I go dot dot, I go up to the parent, and then from the parent I go down to my sibling folder, lab 0201, and then there's the main file in there. And that's my source, dot dot slash lab021 slash main.cpp. That's the source argument in the command. And then the destination argument is dot. So that means put it in the current folder. I probably don't need to do that, but just to check it, it's there. And here we want to display a triangle. So the triangle is going to have, dots in it. Let's see. It's going to look like this. This looks like spaces between those dots. Let's just print the base. Let's print the base of the triangle. There it is. So we get those those stars. So just above it, looks like we need to go over one space here, and remove a space here, right, and then have another star there. Let's do that. All right, that's the next step. All right, so we're just building it up one step at a time. And we just basically continue with that. I think it looked prettier. Just put one little space in there. Makes the source code look nice. All right. There it is. That's problem 2. Okay. Any questions on that? Nothing really there. This is easier than the first problem. So let's commit now. We're going to go up to the parent folder, and we're going to add main, and then we're going to commit. 3 steps. Let's go to the parent folder. Let's add. So it's Svn space add main, and let's commit. I'm going to do this a little differently. I'm going to say lab 2 exercise 2. Now, don't put any underscores in the comment. I don't know how to put an underscore. Maybe you need to escape it or something, but underscores are not working in that comment field. So make sure you don't put an underscore there. Let's see how it. Let's instead of being everything I do is like works, right? But when you go to the lab, everything you do breaks. So let's try to break it. No, it worked. Oh, okay. Something happened between last quarter and this quarter. All right, let's see. And if we go into this Labo 2, there it is. Here's our triangle. It's committed. So we verify that our work is done. Now we log into Blackboard and go to Lab 2 report and say, yes, I did problem 1. Yes, I did problem 2, and then submit your Blackboard lab report. And then you're done. That's how you finish this lab. Here's some additional notes. Huh? Do not submit the code in Blackboard. You are submitting the code through the repository. In Blackboard, you just say, I did it. Actually, it's a text field. You just type in, like you say, YES. Because Blackboard doesn't always do what you want, and I want it to be able to accept a grade. So the grader needs to go into Blackboard and assign a grade to your assignments. So you have to type in like yes into Blackboard. Yes, I did it. I guess that's it. It sounds like we're done. That's a loud and clear message. So I'll see those who need help today. I'll be in my office this afternoon. If you're having trouble, please come by and get me. Don't hesitate to get me. Huh? My office is in the 3rd floor of Jack Brown Hall, JB 340. Yeah.
We had lab on Monday, but Monday is not.
I mean, I pushed everything back. You notice there's only 9 labs this quarter. So I took one out already.
I haven't paid for my class yet because
Yeah.
this is the first chance I've had to do it, so I'm going to actually go down.